Welcome back to the channel. Today we've got a little bit of code review on some Rust code to do. I was having a conversation on Twitter with Leonard, who was asking about some JavaScript libraries that they use that they would like Rust replacements for. So I suggested Dialogger because that happens to be the tool that I think is the most appropriate for what they were trying to do. And then they came back and said, hey, I got all of this working. Thanks. Any suggestions, let me know. So I figured that instead of just kind of typing this on Twitter, which is, a little bit rough, we would do a code review and a little bit of a refactor. The program they already have here is in their Portfolio V2 repo. So I've already brought down this code so we can take a look at it here. So inside of the scripts directory in this repository, they have a script called garden. It's in source bin. So this will mean that we do cargo build bin garden or cargo run bin garden or something like that. So I'll just kick that off while we talk about this a little bit. Now, I think that this project in particular is a really, really good choice for people who are just getting into Rust, who are writing their first Rust scripts, Rust programs, that kind of thing. This particular script is a couple of interaction prompts on the CLI. So ask for a title, ask for a date, whatnot, and then write a file out. So it's basically templating out this the front matter for a file that they're going to use to write a blog post. And this kind of isolated use case is really, really good. It's one of the things that I teach in the Rust Adventure workshops. In fact, with color air and things like that as well. Let's get into it. So the first thing we do is we've got a main function that returns a result. This is fantastic. They install color air immediately after this, which is exactly where you're supposed to do that. And what this means is that they will be able to use this question mark throughout their entire application. It makes the return type here a color air report, instead of just kind of like an IO error or a specific third-party crate error or something like that. Color error is a really good choice here. You could also use anyhow or Miet, or I think there's at least one other package that is similar to those. So let me get into a couple of like what looks like constants to me. We're not going to do any refactoring yet. We're just going to go over, take a look at what it looks like. So we get these two arrays basically of a bunch of string slices. We know they're string slices because string literals in Rust are string slices. They bootstrap a new colorful theme. Colorful theme comes from Dialogger. So they're looking for colors in this script. It's really like kind of a one-off script for them. It's not something that they're going to like pack up and send to crates.io and have a bunch of other people download and whatnot. We use colors here, and we don't anywhere in this program discover whether colors should be supported or not, because this is just their script and they want colors. So as long as they know that, totally fine. We do a date time local here and then format it into a string of year, month, date. Local dates always scare me. I prefer to use like global dates instead, or global date times. But if that's what they want, that's what they want. That's totally fine. Then we get to current working directory, and the current working directory function from standard env fails. And they're choosing to unwrap here. And you see as I highlight the unwrap, they actually unwrap in a bunch of different places. So that's going to be one option for us to swap that right over to a question mark later. Interestingly, they stop, like current dir returns a path buff, right? So you can see that the type here of CWD is a path buff. What this program does is it sort of like goes to string lossy, which really shouldn't do much in this case, but they start dealing with strings from here on out and not path buffs. After that, we use Dialogger to request a couple different fields, things like the title, the date. We use slug to slugify the title into a file name, basically. This is just a renaming of the date. So last update pointing to the value and date. And then we do a couple multi-selects. We do a select. These selects and multi-selects return the index of the values that we initialized earlier. So tags choices and icons choices get shown here as strings. And then when the user picks one and returns it, we get basically an index into that array. This file name is basically just formatted with the current date and the slug with 2 dashes between it. This directory path is where we start to see some of that conversion from a path buff to a string have effect. So they've chosen to go with format and some display formatters with hard-coded slashes in between, instead of doing something like pathbuff.join, which we'll look into later. And then they do the same thing with the file path. I think they use directory path. Yeah. Okay, they use directory path later. And then they go for tags formatter. Tags formatter, they create a new string. Totally fine that you can create a string like that. I think that this whole section right here is really just for creating a YAML list with dashes for a bunch of tags that should be applied to the blog post. And in this case, we're just like kind of pushing this onto the string mutably. I think there's a couple things we can do here that we'll look into. But what we end up with here is basically front matter with 3 dashes in the front, 3 dashes in the back, and all of the front matter values properly formatted, basically. There's a couple toStrings scattered around here that I'm not sure are strictly necessary. And then we print line. So we print line a couple of informational things out. I think this is okay because it's a script, it's one-off, it's something that they're running on their own computer. Makes total sense that they would use it in only the way they expect to use it, which is one of the nice things about building your own tools. If this was a more general use kind of tool, maybe I wouldn't use print line here, but they do it in a couple of different places to output sort of like debug information for themselves. And then we have this confirm with theme. This is basically like, hey, here's all of the values for the front matter. Do you want to continue? Should we write this file out? And this is a yes or no. They choose to always return okay here and print out an aborting. I'm not entirely sure why that decision was made. I think if you're aborting, it probably should be a error exit code. So we'll get into that later. And then when we have the directory path, we basically make dir-p, or we create all of the directories up to the file path, and then we write the front matter into the file path. So at this point, we've successfully scaffolded out a new file with a bunch of front matter, and that's quite nice, actually. So let's run this. Cargo run bin garden. Let me make this a little wider. Some title. See, we've got a date with a default. We can choose our tags. We'll choose like Discord and freebie. We'll pick an icon. It'll be Discord. We get the file 2022-123. Some title will be created with this front matter. You can see that we've got the tags formatted as we expected to have them. And do we want to continue? Yes, we'll continue. Okay, so we successfully created this file. And if we cat it out, what we get is the front matter. So that's wonderful. Let's take a look at the error case as well. So we get the title, the date, some tag, some icon, and then we say no, and we just get aborting, and it doesn't look like an error or anything, but it's just some text printed to the console. That's what the script is. Again, I don't think there's anything wrong with this script. It works. It does what they want it to do. It's a one-off script. This is one of the reasons that I suggest people do this in the first place. It is not something you need to run consistently in production for months at a time. It doesn't need to be industrial strength, as it were. And like, for example, we're going to remove a bunch of these unwraps. The unwraps are fine. Like if you're just learning Rust, the unwraps are fine. Don't feel bad about doing that. In any case, we are going to refactor this. We're going to make a couple decisions here that change a few things about the application, and I will explain what they are as we go along. So here I'm taking out these, what I feel like are consts, and they'll be arrays of string slices, and they both have to have a number. So let's actually show that off for a second. So if we do this and we try to run the garden, what we end up with is doesn't have a size known at compile time. And that's because arrays can be, any length. In this case, we have a specific length. It is 22 minus 10, so 12. So as soon as we put the length of this array in here as the type, everything's fine. And I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 here. And we will just put 10 in here. This is the easiest way to do this. We also get a warning here. Help convert the identifier to uppercase. We will choose to do this in both cases. You can do that in VS Code like I just did. And we're just going to kill the process because we don't really need it. So we have these consts here now. We do need to now go in and select all of these, and we'll uppercase those. Will this select me? Yeah, this will select me all of them. So we'll uppercase those as well. And now we just have these uppercase consts embedded in our binary. Basically, I chose to make these consts because they don't change. We don't do anything with them. They're hard-coded into the binary. So this is an array that I want basically set up at compile time, right? This is never going to change. There's no real reason to define it repeatedly inside of the function. So as we move down this application, we can see that we've got datetime local and now.format. I'm not going to touch the datetime local. I assume that that's just the way they want to do it. So we won't change that to a global date or anything like that. We'll move down here to the current dir, which I believe is something that we should change here. If we look at the types again, we can see that current_dir returns a path buff if you unwrap it. The first thing we'll do here is instead of unwrapping, which will panic, we're going to handle this with a question mark. And what the question mark is going to do is return an error from the main function if something goes wrong, instead of panicking if we unwrap. Because we have color error installed already, what this means is that we get a nice output if something goes wrong with the line number and other additional information. Whereas if we use panic just sort of like kills the program immediately, right? So ideally, we don't want to panic as much as possible. And if you're unwrapping or .expecting or something like that, it should be for cases that should never happen. So in general, if you are writing a program and this is an application level program, it's not a library or something like that, we have color error installed, we should use question mark to handle these errors because it will allow our program to finish up, deallocate anything, that kind of thing, drop any values that it needs to drop. Whereas panic is sort of like, oh no, and just immediately stops the program, doesn't let it do anything. So we've got this path buffer here, right? And we don't really need to convert this at all. So I'm just going to remove the line that converts it to a string and name this current_dir, which is the name that we use later on in the program. So now that we have current_dir here, we need to change this from being a string to being a path buff. So I'm going to use .join here, and I will remove some of these sort of external quotes and stuff. And then we .join again, file name. And what we end up with here is the path buffer with the join function that we have on a path buffer. And we're not going to add an absolute path here. We're going to add www content garden and file name. Now we could split this up into .join again. I chose not to because I assume that Leonard knows where they're running this application and that this is actually what they want to do. But we could, just to be clear, join together a whole bunch of things. And that means directory path is also going to be a path buff. So we've taken our path buff, we've .joined, which is a non-mutating function. So what we end up with here is a directory path that is basically a new path buff. And we get to do the same thing here. So let's take directory path, bring it over here, and we'll do .join, and it will be index.mdx. And now file path will also be a path buff. So now you see by using the actual path buff data structure, we have sort of eliminated some of the error that we could have introduced as humans when we write this in the path construction. I think that's it. The only thing left here is that, let's build this because I think we might use this in another place. So instead of running, I'm going to do a .build. And basically the error here is path buff cannot be formatted with the default formatter, which is totally true. It cannot be. There is a package that will let you do that if you are so inclined that you want sort of a more robust handling of paths, because basically everything is UTF-8 these days. And the Rust standard library has to account for the fact that some things aren't UTF-8. If everything that you're going to be dealing with is UTF-8, I would highly suggest using Camino for your paths. In this case, it doesn't particularly matter, but Camino is the sort of industrial strength handling those kind of paths go. So instead, since we're not using Camino, we can do pathbuff.display, and that will give us just a display version of our file path. And it doesn't need to be correct because all we're doing here is saying, hey, we successfully created a file at this path. So now we're left with a value borrowed here after move error for file name. That means we are also using file name somewhere above it, like right here. And all we do is we borrow file name up here. So if you have a value borrowed after move, then what you have to do to fix that is at some point what you're doing is you're moving the variable into a function, you're moving it into something and moving it into a closure, you're using it somehow, you're using it up. So in this case, what we need to do is say, hey, we're going to let you look at this, but don't use it up. Don't transfer ownership. And that allows us to then use file name down here however we want, because we've now chosen to borrow earlier in our program, which means later in our program, we still have it around. So if we build, that's all good. So current_dir, now a path buff. Everything's great. We don't have to convert lossily to a string and then back. We get to just use path buffs everywhere. Much better. Now we have a couple of things here. Basically, these are all asking the user for input. And while they should succeed, sometimes they could possibly not. So they do return results, which are either the actual value. In this case, he's hard-coded some types here. So title as a capital S string and date as a capital S string. In some cases, you can see the other types that would be here, like slug and tags as a vec of use sizes because they're indexes. So in all of these cases, I'm going to just remove these unwraps and replace them with a question mark. So if anything goes wrong here, it returns from the top of our function instead of panicking. And thus, when it returns from the top of our function, color error can handle it and show it to us in a nice way. This also means that we get to add more context here to this error if we want to. I'm not going to do that right now because, like I said, this is kind of a one-off script, and I don't know that we need that much more context. We will always have this file around. The use case of this is going to be cargo run garden and then it running. So we'll always have this source file around. Now we've got current date here. We stringify current date. I'm going to leave that. I'm going to assume that that's just what they want to do. Right here, we've got last updated equals a reference to date. I don't think we need that. We can just do last updated. So moving on in our application here, we get down to this tags front matter. And this tags front matter can definitely be done in a different way. So basically what this for loop is doing, right, before I write this, let's say we're initializing a new string called tags front matter. And for every tag in tags again is the tags that the user has chosen to apply to the blog post in the front matter. For every tag that they've selected, tag is a use size. So it's an index into that array. And we're taking tags choices tag, which just gives us the string slice back. And what we're doing is before every one of them, we're adding 2 spaces, a dash, a space, and then the string slice at the end. This is what gives us the YAML-like output of a list. So we'll take this front matter and we will turn it into tags.iter. We'll map over, I'm going to call this tag index in each case. We're going to map over that. We're going to get the tags choice, the string slice out. We're going to map again and then format that string slice. We could do this in one map. I'm just doing it in 2 for clarity. And then we collect. And when we go to build this right now, we're going to get a specific kind of error. Slice indices are of type usize or ranges of usize. The type static string cannot be indexed by a reference to a usize. Now this reference is very important, right? This reference is the problem here. It says slice indices are of type usize or ranges of usize, not reference to usize. So this reference here is very important. We have 2 options here. We can dereference it, which will work, and that will allow us to move on to the sort of the vec issue. The vec issue here being, hey, we've chosen the wrong thing. So really what we want here is a string. The other option for tag index is that we can do into-iter. Into-iter will give us ownership over the U8s that come in through tags, which means that we don't need to dereference them, because if we look at the types here, we now have a usize here. Whereas if we use iter specifically, we have a reference to a usize. And that's the major difference between iter and into-iter. Into-iter will give us ownership. Iter gives us references. So I'm going to leave this as 2 maps for now. I've done 2 maps very intentionally because we're going to make a change here in a second. But we can now get rid of this for loop that is like mutably collecting into a string. And we can use a more rusty idiom, which is basically taking the list of tag indexes, mapping over them to turn them into string slices, and then mapping over them and collecting to turn them into one giant string. Now, I very intentionally did this first map here. So let's take this map out and let's go back up to the tags select here. And in the tag select, what we end up with is a vec of usizes. But what we want is not actually a vec of usizes. What we actually want here is a vec of string slices. And we want string slices because these indexes don't really hold any meaning for us. All we want out of this select here is the actual tag names. I've chosen to take that in right here and do basically the same thing we had up until this point. Then you'll see that the question mark here can actually handle midstream, I guess we'll call it. So if I didn't have this here, this would be an issue because interact returns a result, but we can handle that result mid function call basically, or like not mid function call, but mid chain of functions, because all this is it desugars into like a, hey, if it's an error, return it from our function. If it's not, return the value. So what we end up with here is actually the result of this, which is a vec of usizes, which means that we can then into iter to gain ownership over those usizes. Did I save this? I didn't save the file. That's why that red squiggly line was there. We can into iter to gain ownership over the use sizes like we did before. We use the exact same .map that we used earlier, because what we've got here is a vec of, vec of use sizes. And we turn that into our vec of string slices. And now we've got tags. We actually have tags. And I think that moving this manipulation of the use sizes into string slices into the place at which we are selecting the tags makes a lot more sense than leaving it somewhere else in the program. Because now what we have is tags choices. Both of the uses that we've used are in the same spot, and we don't have to search through the file to find them. So as long as we're never going to use those indexes, which we really are not, which leads us to actually be able to do the same thing for icon. So we've got icon choices here. I'm just going to rename this to icon and then go back up to icon here. And I'm going to do the same thing, .map. I'm going to map over choice, and I'm going to do icon choices choice. And note that we've got method cannot be called on use size due to unsatisfied trait bounds. But it's a problem because we did this outside of this question mark. So understanding the types here is super important, right? If we have, let's get rid of the map here for a second. If we have question mark, icon becomes a use size. If we don't have the question mark, icon is a result that could return a use size in the success case, or it could return an error. So if we use .map, we're not going to use .map on the use size type. We're going to use .map on the result type to operate on a success value if it exists. So if we take the question mark and we put it after the map, the .map is now a function that's being called on the result, which if it's an OK variant, if we have a use size, then this function will be called. If it's an error, this will just return to the main function. In this way, we now have a string slice for icon instead of an index into some array that we need to deal with later. Knowing that this .map exists is a really interesting piece of, getting more comfortable with Rust, because .map isn't just for arrays. It's a function that exists on a variety of containers. And you can think of result or option or a vector as all different kinds of containers. So I think that's mostly it. I would also do in here, because this is failing, instead of doing a print line abort, I would probably do an error with an error. And then we don't need the OK here. And we can return this. We do have to bring this error into scope. So this will be error. And then we'll see that this down here actually does work. And what you will get here is actually an error returned to the main function and reported via color error. Instead of everything's okay, we're good, we actually get like, hey, you aborted this. That's a little bit of a personal choice. It's a little bit of a personal choice, especially because we have these print lines here anyway. And sort of like, this is a one-off script. So what you want to do as a result of what this script does is up to you completely. So you could leave that here or not. So then we're returning this error, and the error macro helps us out a bunch. And we can just sort of like write arbitrary strings here. We could add context if we wanted to. We don't really need to. And then finally, I want to make sure that we have removed all of the unwraps in this program, because we're using color error. So this fs creator all gets a question mark. The fs write gets a question mark. They both return results, such as the life of error handling. And that's pretty much it. So we've got this working program again. We've modified a decent amount of it. Again, the program as it was originally constructed worked just fine. It did exactly what this person wanted it to do. We just made a couple of changes to sort of learn a little bit more about Rust and what we can do with it. So if we cargo run bin garden now, a title, a date, some tags, we'll say CLR, elite PvPers, and general. We will pick the MDX. We've got a title, we've got the date, we've got when it was last updated, we've got the icon we want to use, and we've got the tags, and it's all in a front matter. And if we say yes, this gets written out to a file. So let's go check the file, make sure that worked. It worked. If we go through the binary again, and we do this, and we like select some stuff, and we select some stuff, and we say, do you want to continue? No. Now we get this error aborting. You've chosen to abort. And this is where the additional context would show up if we wanted to add that in. This gets even more useful when you start using multiple abstractions. So one of the things this person wants to do as they move on is they want to write another script. And after they write another script, they're going to look to abstract some of these functions into another file. And if you're using the tracing library, what will happen here is that the deeper you go into the stack of functions that are being called, the more sort of context you will get in this error. So if you are going to abort, and this is a couple functions deep somewhere else, you will get a number of pieces of context here that help you understand what was happening when you aborted. And the last thing that I want to do here is just cargo clippy. So if we run cargo clippy, there is a number of warnings. Basically, it's like ESLint if you're used to JavaScript. So here we've gotten a warning to avoid using collect when not needed. Source bin garden rs62. So on line 62, I've collected here, but I don't need to collect here. Now, when we do this, icon is going to be an iterator. So now we've collected, or now we've chosen to not collect, which means that tags is now still an iterator when we go down to use it. So down here in tags formatter, we do tags.intoIter. We don't really need intoIter anymore because we already have these string slices and we're going to map over them for this tag anyway. But this is basically like, if this is all we wanted to do, we could move this up as well, right? We could move this up into here. The reason I had the collect here in the first place is that I think that makes sense more, especially when people are coming from JavaScript. It makes sense to do a few extra collects and have a bunch of vecs laying around, because once you have an iterator here, if you don't understand what you're doing, you can get yourself into a situation where you see a really scary error message or something like that. I don't necessarily think that we need to not collect here, but cargo clippy informs us that we really don't have to. So I'll remove it. So I'll just commit that as code review. And then I think that there's one more thing I want to show off here. As a point of just general Rust things that happen, right? So we've got this front matter here, and what we have is when I see something like this, which is a YAML formatted string that is manually constructed, I immediately think of Serde. There's a reason I immediately think of Serde, because if we cargo add Serde and Serde YAML, clear this, I'm going to construct a struct for front matter here. And now this is sort of like bonus front matter. This is not something that you need to do. These are going to be strings. These are going to be strings. This last updated is going to be an underscore. Here we're going to derive serialize, and I'm going to derive debug for kicks as well, just so that also works. And we do need to bring in serialize, so we'll do use Serde serialize. And you'll notice that last updated is now an underscore. So if we serialize this now, we'll get an underscore. One thing we can do is use the Serde rename all. So if we Serde rename all camel case, what we end up with is when we have an underscore here, this will get translated into last updated with a capital U when we serialize it. Now you'll see that we also still have a red squiggly under serialize and a red squiggly under Serde here. That is because when using Serde like this, we have to enable the derive feature. And we can do that by using version and features equals derive. And now when we build cargo build bin garden, we end up with this, and it just works. Tags itself is not actually a string, it's a vec of strings. So we'll have title as a string, date as a string, last updated as a string. Even though these two are dates, we're converting these dates into strings. So I'm going to leave them as strings to match the original intent of the program. And then icon is also going to be a string. We've used capital S strings here and owned types instead of, like, we could have written like string slice in here. Capital S strings are the default that you should end up with when you create your own structs. They're much easier to work with. Later on, if you see that there's a performance problem or something like that, you can always come in and add references to these, but I would not suggest doing that from the start. So we can do let fm equals front matter now, because we have our own struct. We'll fill the struct fields. Now we're actually going to not do this for the tags front matter. And this is just going to be tags.collect into a vec of strings. And we need to map over this for s.toString because the original iterator is an iterator over string slices. And we need to turn this into owned strings because that's what our struct accepts. So we tags.map.collect into a vec of strings. I believe date is current date or something like that. Yes, current date up here. So this is going to be current date. I think the icon is just icon Let's see what we've got here. Yes. So icon is a string slice because it's a reference into that const that we have at the top of the file. So when we do icon, we can do toString here. Current date, expected struct string found delayed format. That's because of the way that current date is constructed. So last updated is probably really what we want here. And again, just because the name of the variable and the name of the field that we're using in this struct are the same, we can just leave them like this. It's kind of like destructuring in JavaScript. For current date, we'll toString it because that's the delayed format. And you can see that we toString it up here as well. So we're doing the same thing. We are going to get rid of this whole thing right here. So all of this serialization to a string here is now going to be handled by serde YAML. Let front matter, toString, FM. This returns a result, so we'll handle it with question mark. This needs to take a reference, so we will handle that by passing a reference in. And now our build works. So I know that there's still an issue here, and I'm going to show you what it is. But this is one of those things where it's always good to run your applications. Run test, this state. We'll go CLI, I don't know, we'll choose a couple of these, we'll choose one of these, we'll write it out. And then when we go check the file, you can see that everything got written out correctly, including the dashes for each of our vec of strings and things like that. But you'll notice that there's no dash 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 on the bottom. And that's because that's a front matter thing, that's not a YAML thing. So the serialization here that we're using is for YAML, not for front matter. And we can solve that just by doing a format like we were doing before. But now look at how much less string slinging we're doing. We've chosen to serialize the struct that we've created into a YAML representation, which takes all of the little fiddliness out of our hands and puts it into well-constructed, well-tested library code. So just to prove that that works, we can hit yes here. If we cat this file, we now have all of the front matter. And realistically, if I was going to make this something that I used in quite a few of my other like scripts or something like that, what I would do is pull this front matter type out, probably make it post, add a body field, something like that. But that is it. So those are some of the changes I would make. You're free to do whatever you want, Leonard, obviously. These no longer return the index of the selected value, so I'll get rid of these comments. Hopefully that was informative. Yeah, so if you are a person out there that is taking a Rust adventure, or you have a question on Twitter and I answer it or something like that, and you have some code that you'd like me to review, I am happy to do this kind of code review for you. So just let me know. No guarantee, of course, that I do it, but standing offer, I may or may not make a video on yours. Thanks for hanging out, everyone.